Welcome back. So today we're going to be talking about angles and arcs. So we're starting out with some vocabulary. So we have a central angle. A central angle just means that that angle uses the center of the circle as its vertex and the sides are the radii of the circle. Okay, so then we have the central angle sum. So the sum of the measure of all of our central angles, when we add them together, comes up to 360 degrees. So if you look at our circle here, we have 4 different angles that make up this circle that are all central angles. So when we add all 4 of those together, 1, 2, 3, and 4, we get 360 degrees. Okay, so we're going to use that information to work an example here. Alright, so for this first example, we're going to be using this picture, and we're going to find the measure of angle AOD. Okay, so AOD is this larger angle here that's the 25x. Okay, we have a couple other pieces of information that we know here. We have a straight line, which is AB. So we know, since this is a straight line, that this whole thing is 360, so this half is 180. So I'm going to take my 25x plus my other angles, my 3x, plus my 2x, and I know that those are going to equal 180 because it's half of the circle. Okay, so it's not 360, it's only 180 for that piece. So I'm just going to add all of these up. So I have 25, 3, and 2. So I have 30x equals 180. Okay, and I'm still solving for x, so I'm going to divide by 30. So then I get x equals 6. Okay, so then I want the measure of angle AOD, so I'm going to plug that back in. So the measure of angle AOD equals 25 times 6. So then this is actually going to be 150 degrees. Okay? Alright, so then let's look at the next one. Now we have AOE. AOE is this piece here. Well, we know if we have these two lines crossing, these are considered to be vertical angles. So this side has to be equal to these two together. Okay? The other way you can think of it is this one plus this one is the 180. And if you do this side, this one and this one gives us 180. So if we subtract that out, then obviously those have to be equal. So what I'm actually going to do here is I have my 3x plus my 2x equals the measure of angle AOE. So that gives me 5x equals the measure of angle AOE. And we said x was 6, so we're going to plug that in. 5 times 6 equals the measure of angle AOE. So I end up with 30 degrees. Okay, and that's all I have to do on that one. Alright, so this next piece is a big chart. Now, this chart is really important, so please do take the time to make sure that you have all of it. So I'm going to go through these one piece at a time. And like I said, you can pause it if you need to, so that you can get all of the pieces, because I am going to move through it pretty quickly. So we have 3 different types of arcs. We have what's called a minor arc, a major arc, and a semicircle. Okay, so I'm going to go through the minor arc. So a minor arc, here's an example of a minor arc. So that's this pink highlighted piece. So there's a picture representation for you. And when we name them, so I'm actually going to put here, this is to name them. We're going to use 2 letters, and it's usually the 2 endpoints. So the 2 endpoints of my arc are A and C, so this is arc AC, and we put that little arc over the top of it. Instead of a straight line, it's an arc. Okay, and so then the next piece is, how do we measure those? So I'm going to slide this up just a little bit here so you can see the bottom. So the measure of the arc and the central angle are equal. So if the central angle for this one was 110, then the arc is also going to be 110. Central angles are always equal to the arc. Okay, and those are in degrees. That's not length, that's degrees. That's 110 degrees. Okay, so then I'm going to slide this back up. So then for a major arc, so a major arc is this big arc here. For that one, we actually use 3 letters. So we're still using the 2 endpoints, but now we're using one other point that's on the arc, so that way I know I'm going this direction instead of just the minor arc. Okay, so for this one, I have E and D, and then in the middle here is F, so I'm just going to go around. So D, E, F. You can go either direction here, so it could be E, F, D, or D, F, E. Either way. And then again, for the measure of that, you can do it 2 different ways. If you know this larger angle, you can use that. Since we only know this smaller angle, we're going to take 360, which is the whole circle, and subtract out this piece. We're going to cut that out. So 360 minus our 60 gives us 300. So if I slide down here, you can see to do the measure of that arc, we're going to take 360 minus the minor arc, which is greater than 180. So 360 minus 60 is 300, which is greater than 180. Okay? Then for a semicircle, we use this just a little bit on that last example. Semicircle cuts through the middle. That's a diameter there. So we're going to be using, again, the 2 endpoints as well as one other point along that arc. So JML is one of them. We also have JKL. You could have also went the other way. And those are going to be exactly 180. Okay, it's half of the circle. It's 180 degrees. So then the last piece that I have on this page before we work some examples is the arc addition. So just like we had segment addition and angle addition, now we have arc addition. So if we add together 2 pieces of a bigger arc, it's going to give us that measurement. So I have PQ, which is going around this way, and I have QR, which is going around here. So they don't overlap. If I add those 2 together, I'm going to get the length of PQR, which is the whole thing. And that's all that arc addition is telling us. Okay, so let's get to the examples. So we have an example here. We're going to do a few different things. So for this one, we're looking at circle F. We have the measure of angle DFE is 50. So I have that marked on there for you. And then we also know that CF is perpendicular to FB, and I also have that marked with this right angle symbol. Okay, so we're going to be finding 3 different pieces. The first one is BE. We're going to be finding arc BE. That's this arc right over here. Okay, well when I look at that one, I can see that DE and AB intersect. Those are straight lines that intersect, so that means these 2 are vertical angles. So vertical angles are congruent. So BE is equal to AD. So that is 50 degrees. Okay? Sorry, that's supposed to be an M. Alright, for the next one, we're looking at CBE. So CBE is this bigger one here. So we just found this to be 50. We know this one is a right angle, so that's 90, so we're going to do that arc addition. So we have 50 plus 90 gives us 140 degrees. Okay, we know this one is 90 because that's a right angle, it's perpendicular. Alright, so then the last one that we have is ACE. So that's starting here. We've got A up here to C and then all the way around to E. So we're going to be adding some things together. You can do this several different ways. You can take each angle individually, but I know AB is a semicircle. So I'm going to take ACB, which is 180, plus BE, which we found to be 50, and I'm going to add those together. So I actually end up with 230 degrees. Okay? 230 degrees there. Alright, so let's go on to the last little bit then. So I have a formula for you. This is for arc length. If you remember before, I was telling you those were in degrees. This is to actually find the length of it, not just the degrees. Okay, so we have arc length. We have two different formulas here. You can either do A divided by 360 equals L, which is the arc length, divided by 2 pi r, which is circumference. Or we can say circumference times A over 360 equals L. So where this comes from is they just took this bottom piece and multiplied it by both sides, so they moved it over here so L is by itself. Because most of the time we're solving for L, so we want it to be alone. Okay, so then we're going to come down here and we're actually going to work a problem. So I'm going to go ahead and bring my formula down. C times A over 360 equals L. So then I can slide this up a little bit and we have more room to work. Alright, so then for this one we have circle P. We know that PR is 15 and we know that the measure of angle QPR, which is this bigger angle here, is 120 degrees. We're going to find the length of QR. QR is that arc there. Okay, so in order to do this, we're just going to plug in some information to our equation. So for circumference, since I know radius, I'm going to use 2 pi. My radius is 15, so I'm going to plug that in there. So that's C times A over 360 equals L. So what is that A? We haven't really talked about that A piece yet. That is just your angle. So my angle is 120, so I can plug in 120 here. Okay? So now I have 120 divided by 360 times my 2 pi times 15. Okay? So then from here, I'm going to go ahead and simplify this. So I have 30 pi times my 120 over 360. That actually reduces down to 1/3 equals L. Okay? So then from there, I'm looking at this 30 and this 1/3. Well, 30 divided by 3 is 10. So I have 10 pi equals L. Okay, my 30 and my 3, I can reduce that. 30 divided by 3 is the 10. So that's where I got my 10. 10 pi equals L. If you want to go ahead and plug that in, you can get an approximation. So we would get 31.42 is approximately the length of L. And since we don't have centimeters, meters, anything like that, we'll just call this units. Okay? Alright, so that is all I have for you today. Have a great day, and I'll see you in class tomorrow.